Jai Hind. The topic for today's lecture is serializability. This topic has been covered in Unit 4. So before serializability, we need to understand where this concept falls. It comes when your transactions, they are executing concurrently. So first, we need to understand what is the meaning of concurrent executions. So when the multiple transactions, they are allowed to run concurrently, that is simultaneously in the system, and they are working on the same records or same sets of data, then we say that they are executing concurrently. And why we require the concurrent execution? For the increased processor and disk utilization. And if we run multiple transactions together, for example, I'm having 3 transactions, T1, T2, T3, and I'm running simultaneously all the 3, then in that case, my system throughput will increase. So one transaction can be using the CPU while another is reading or writing to the disk. Another important advantage is the minimum your response time. So we got the reduced average response time for transactions. So in this case, short transactions, they need not wait behind the long ones. So concurrency control schemes, what are they? They are the mechanisms to achieve the isolation. That is when we are talking about the concurrence, and which property, asset property we are emphasizing, we are working on the isolation. So what the isolation says? It says to control the interaction among the concurrent transaction in order to prevent them from destroying the consistency of the database. That is, all the transactions, they are running unaware of each other. So when we are going to discuss the schedules, serializability, we need to understand what is the meaning of a schedule. So what is a schedule? When several transactions, they are executing concurrently, then the order of execution of various transactions are known as schedule. For example, I am having 2 transactions, T1 and T2, and here, for example, I am having these sets of instructions where A and B are my data items. Then in that case, this particular snapshot which I have taken at a particular time, it is my schedule. So what is in a schedule? We have a set of transactions, and they must consist of all the instructions corresponding to those transactions, and must preserve the order in which the instructions appear in each individual transaction. That is, I cannot swap these 2 orders. So a transaction that successfully complete its execution will have a commit transaction as the last statement. That is, once your transaction got complete, here we are having a commit instruction. A transaction that fails to successfully complete its execution, then in that case, we need to abort the transaction. There is a category of a schedule which is known by the name serial. That is a serial schedule. That is, if all the operations of each transactions are executed consecutively, then we say that it is a serial schedule. Otherwise, it is a non-serial schedule. For example, this is an example of serial schedule. That is, first the instructions of transaction T1 is coming, and after that the instructions of T2 is going to be executed. In this particular schedule, what we are doing, we are transferring the amount $50 from A to B, and in transaction to T2, what is happening? We are increasing the 10% of balance from A to B. Transferring the 10% of the balance from A to B. So this is a schedule. In this case, all the instructions where we are updating A and B data item, they are coming, and in this again A and B. But the thing is that this is an example of a serial schedule, because all the instructions corresponding to T1, they are executing, and once they complete their execution, only after that the execution of T2 starts. But there is an alternative to this. For example, read A, then whatever you are doing, the updations you are updating, and after that, this is my T1 and this is my T2. Again, I am doing whatever be the my you could say processing steps of execution I'm doing, then and after that again I'm completing till WB and again RB and after that WB. Then in this is again the example of serial schedule. So what is our serial schedule? Basically here we are completing in T1 once the working on data item A completes, only after that the working of A in T2 starts. This is another example of the serial schedule. So this is again I have already explained you this is a serial schedule, but in this case we will say it is equivalent to schedule 1, that is it is equivalent to my serial schedule. So in all the three concepts, that is a serial schedule, what we got, the sum of A plus B is always preserved. This is the concurrent schedule, but it does not preserve the value of A plus B, and therefore it is not an example of a serial schedule. It is a non-serial schedule. Why? Because we have not completed the writing part of it. That is, you have done the updation on the A, but you have not written that A successfully to my table. Whereas you started working on A. So in this case, my A value, it will become inconsistent. Similarly, here you have just read the read value, but then my processor, it shift to the transaction T1, and here again you start reading the value of B and you are doing certain updation, but this updated value is not reflected here. It is still working on the old B value and doing some updations on the B value. So this is a non-serial schedule, and in this case A plus B value is not preserved. So serializability, here we took certain assumption, that is each transaction preserves the database consistency. The serial execution of a set of transactions, they preserves the database consistency. So once we are talking about the concurrent execution, what is our main motto? Our main motto is that they should be either the serial, execute them serially, or execute some schedule which is equivalent to a serial schedule. So a possible concurrent schedule is serializable if it is equivalent to a serial schedule, and we are having two types of serializability. One is conflict serializability and another one is view serializability. Once we are going to discuss, then we just focus on these two operations other than how we are doing the calculation. So in the next slides, the schedules, they won't contain any processing part on A or B or any other data item. They are going to contain, just focus on the read and write instructions. So before going further towards the conflict serializability, we need to understand what is the meaning of conflicting instructions. So if I am having two transactions, Ti and Tj, and I am having two set of instructions, that is write and read in both the transaction or certain data item Q, then in that case there are four possibilities. Here I it corresponds to transactions Ti, and Ij, it corresponds to instruction transaction Tj. So the very first combination is in the transaction Ti, you are reading Q, and Tj comes, it also wants to read the Q value. Then in that case I and Ij, these both instructions, they don't conflict. Whereas other three, that is read, write, write, read, and write, write, in all the three cases they are conflicting. What it says, suppose your transaction T1, it is reading certain item, T2 comes, it wants to write on this data item, then in that case it will conflict. Or T1 is writing and T2 also wants to write, then again this is my conflicting instructions. So a conflict between II and IJ forces a temporal order between them. That is, if II and IJ are consecutive in a schedule and they do not conflict, then their results would remain the same even if they had been interchanged in the schedule. What it implies? That is, if in T1 and T2 it is, or we swap these order, then again the results are going to be consistent. So what is conflict serializability? If a schedule S can be transformed in another schedule S dash by a series of swapping the non-conflicting instructions, then we say that S and S dash are conflict equivalent. And if one of them becomes a serial schedule, then we say that it is a conflict serializable schedule. So now we have identified 3 rules that shows that if 2 operations in a schedule satisfy all these 3 conditions, then operations are said to conflict. Either they belong to different transactions, they access the same time, and at least one of the operation is a write item. So here this is a schedule 3. Here we are having read a, write a, then again these and these. So what? Here the data item is A and here the data item is B. So in this case, what is happening? We are working on different data items. Then we can bring this up and this whole set of instruction down. That is, we can interchange them, their order, and we get this particular thing which is a serial schedule. So in this case, we can say that it is equivalent to this serial schedule and it is a conflict serializable schedule. This is another example, but in this case you cannot interchange the instruction. That is, you cannot do like this because this is an example of a conflicting instructions. We are unable to swap the instructions in above schedule to obtain either the serial schedule T3 T4 or T4 T3, and therefore it is not conflict serializable schedule. Another concept is view serializability. View serializability says that we are having 2 schedules S and S dash. S and S dash, they are view equivalent if the following 3 conditions are met. All the 3 conditions, they need to be followed. The very first, what it says, for each data item Q, if transaction Ti reads the initial value of Q in schedule S, then the transaction Ti must in S dash also read the initial value of Q. That is, if I am having this, for example, this is S dash, here I am having 2 transactions T1, T2, here I am having 2 transactions T1, T2. Here if T1 is initially reading the data item Q, then in S dash also T1 will initially read the data item Q, whatever be the order. But in both the schedules, the transaction T1 will initially start reading Q. That is, in this case, if I am having T2 who is reading first RQ, then it will violate the first property. First, we will see the third property. What it says, for each data item Q, if the transaction that performs the final write, then in S dash also that transaction will perform the final write. That is, if my T2 is finally writing on data item Q, then in S dash also T2 will finally write. T2 is going to be the last transaction who is updating or who is writing on data item Q. Now come on this important property. What it says? It says that for each data item Q, if transaction Ti executes read Q in schedule S, and that values was produced by a write Q operation by the transaction Tj, if any, then this order should also remain maintained in the S dash schedule. That is, I am having this order. For example, here I have written on A, and that is T1 is reading A, which was previously produced by T2, then this order should also remain maintained in S dash. That is, in S dash also T1 will read that value which is going to be written, which was previously written by the transaction T2. If all these three properties they are followed, then we say that S and S dash, they are view equivalent. If any one of them is my serial schedule, then we say that it is a view serializable schedule. So for each example is not view equivalent to schedule 2, that is schedule 1. Here I am having the schedule 1. So this is, and this is my schedule 2. Both are serial schedule, but they are not view equivalent. Why they are not view equivalent? Because in this case, what is happening? Here T1 is initially reading the data item A, whereas in T2, A is initially read by transaction T2. So in this case, the very first property got violated. Also in schedule 1, final write operation on the B is being done by T2. Similarly, final write on A is being done by T2, whereas in schedule 2, what is happening? Final operations on A and B, they are being done by T1. So last property got violated. The second, the middle one property, that is T2 is reading that value which is written by T1, and this rule also got violated with the schedule 2. So they are not view serializable schedules. Here we are having schedule 1 and schedule 3. If you look here, then it is, let's check the very first. Initially A satisfied, initially B satisfied. Now look on the final write being done by these T2, and here also final write being done by T2. So first and last property satisfied. Now come on the middle one, second property. In this case, what is happening? Read A written by T1. So read A written by T1. Read B written by T1. Here read B written by T1. So all the three properties, they are being satisfied. So this is an example of view equivalent schedule, and here schedule 1 is my serial schedule. So this is your view serializable schedule. So a schedule S is view serializable if it is view equivalent to a serial schedule. Every conflict serializable schedule is also a view serializable, but vice versa is not true. And this is a very important property. That is, sometimes in exams, the question comes to check for both conflict and view. First, check for the conflict serializability. If it is a conflict serializable schedule, then there is no need to check for the view serializability. But yes, if it is not conflict serializable schedule, then you need to go for checking for the view serializable schedule. So below is a schedule which is view serializable, but it is not conflict serializable, since every pair of instructions conflict and thus no swapping can be done. So every view serializable schedule that is not conflict serializable schedule has blind write. Another important property, that is, which is not conflict, then either of the transactions, one or two transactions, they are having the blind writes. Here we are having blind writes. No read operation has been done in transaction T4 and T6. Now the question comes, how we will check the serializability. For checking the serializability, we make a graph which is known by the name precedence graph. It is a directed graph which consists of the edges and vertices. Here vertices, they are my transactions, and edges, they are inserted between the transactions, and every edge is having the data element on which it is working. So every arc is a labeled arc. So here we construct a directed graph. This graph consists of VNE. The set of vertex consists of all the transactions and how we insert the edge. So the set of edges consisting of all the edges Ti to Tj for which one of the three conditions hold. That is Ti write Q, Tj read Q. So we insert the edge Ti to Tj. Similarly, Ti execute read Q before Tj execute write Q. Similarly, Ti executes write Q before Tj executes write Q. Then in that case, we will insert a edge. So here, our schedule is conflict serializable if only, if and if its precedence graph is acyclic. If it contains the cycle, then we say it is not a conflict serializable schedule. So we run a cycle detection algorithm. Now the question comes, if it does not contain the cycle, now the question comes that in which order we are going to execute the instructions. So for executing the instructions, we do the topological, you run the topological sorting algorithm on the graph, and with the help of topological sorting algorithm, you will get in which order you are going to execute the transactions. So here, this is my acyclic graph. So it is a conflict serializable schedule. In this case, when I run the topological sorting, I got two orders. So if I run my transactions in any of the two orders, that is Ti, then Tj, then Tk and Tm, then my data remains, my database consistency remains same. So these are the references which I have used for making the for preparing this lecture. Thank you and Jai Hind.